Good evening everyone, welcome to iQuanta. So, in the series of quantitative aptitude formula revision on very high demand, we are going off track a little bit, and instead of completing algebra, we are now discussing formulae based on geometry. Okay, and in geometry, today's session is going to be based on lines, angles and properties of triangles. Okay, so are you guys ready? All of the concepts that you will need to solve problems will be discussed here. Okay, and if required, we are also going to discuss few examples as well. All right. मंथन, यस, अनफॉर्चुनेटली एक लेक्चर पेड बैच में चल रहा है ऑलरेडी, आई नो दैट, बट दिस यूट्यूब सेशन इज़ फॉर ऑल, दिस फॉर्मूला रिविजन सेशन. ओके, सो if you want, you can attend any of those two sessions, it's up to you. All right. So if we start the formula revision in case of lines and angles, what do we know? First of all, we are going to understand different type of angles, है ना? So type of angles, है ना? So first of all, first one is acute angle. If we talk about acute angle, what do we know? That theta, the angle theta must be between 0 to 90 degree, है ना? Something like this. The angle will look like this, है ना? This angle theta is between, है ना, 0 to 90 degree. Then second is right angle. Right angle where we say theta is equal to 90 degree, and then comes obtuse angle where we say theta is greater than 90 degree but less than 180 degree. And if we talk about straight angle, so by straight angle we mean theta is equal to 180 degree. And then comes reflex angle. What is reflex angle? Where theta is greater than 180 degree. And then comes complete angles. Complete angle. This complete angle where theta is equal to 360 degree. है ना? The angle is 360 degree. So these are the type of triangles that you will see in the questions. Now after this, if we talk about the combination of angles, so one of them is complementary angles. In case of complementary angles, what do we know? If there are two angles, theta 1 and theta 2, then their sum is equal to 90 degree. Then these two angles are known as complementary to each other. Okay, theta 1 is complementary to theta 2, theta 2 is complementary to theta 1. Then second is supplementary angles. Now in case of supplementary angles, what we can say, if there are two angles theta 1 and theta 2 which are added up to 180 degree, then we can say those two angles will be supplementary angles, like 10 degree 170 degree, 20 degree 160 degree, 30 degree and 150 degree, and so on. So these two angles are complementary angles. Now apart from complementary angles, if we check another types of angles when two or more than two lines are intersecting each other, you can see there are angles theta and theta. These two angles are known as vertically angles, vertically opposite angles, which are known as theta here, are equal. Then other two angles, this is alpha, then this will also be alpha, you know? And in this case theta plus alpha will be equal to 180 degree, or we can say theta and alpha are nothing but supplementary angles, right? Or theta and alpha make a straight angle. Now when two lines, two parallel lines are there, and there is one transversal line. Okay, in that case, what we can say, all the angles, all the acute angles will be equal. Okay, if this angle is theta, this angle will also be theta, this will be theta, and this will be theta. You know? Similarly, if this angle is alpha, this angle will also be alpha. Then again, these two angles will also be alpha. Then any theta plus any alpha will be equal to 180 degree. You know? In any two parallel lines, when there is one transversal line, you know? So this is the relation between the angles that you get. Okay, there will be 4 acute angles, there will be 4 obtuse angles. All the acute angles are equal, all the obtuse angles are equal. है ना? ठीक है? Then we will come to the proportionality concept. What is proportionality concept? Let's say there are 3 lines and there are 2 transversal lines. है ना? Let's say these points are P, Q and R, and these points are M and K. Then the proportionality theorem says that PQ upon QR is equal to Mn upon Nk. This is the proportionality theorem. Okay, the ratio of corresponding regions, the ratio of corresponding segment will be equal. PQ upon QR is equal to Mn upon Nk. Or we can also say that PQ upon PR will be equal to Mn upon Mk, and so on. So whatever segment you are taking here, you need to take the same segments here, and the ratio will always be equal. Okay. So these are about angles and the lines. Now if we come to triangles and if we learn about properties of triangles, then what do we know? So in any triangle, let's say A, B and C. In triangles A, B, C, the side length against vertex A is known as A. The side length against vertex B is known as B, and this will be C. Now in any triangle, what are the properties that we should know? First one is angle BAC plus angle CBA plus angle ACB is equal to 180 degree, which we also known as sum of all the interior angles of a triangle is 180 degree. Okay, sum of all interior angles of a triangle is equal to 180 degree. Then if we extend one of the lines of this triangle, let's say this point is D, then this angle is exterior angle. This angle is known as exterior angle, and any exterior angle, in this case ACD, will be equal to angle BAC plus angle ABC. Any exterior angle is equal to the sum of opposite interior angles. These two, angle A and angle B, will be known as opposite interior angles with respect to ACD. Okay. Now, then the third point, that sum of any two sides must be greater than the third side. Sum of any two sides must be greater than the third side, meaning we can say A plus B will be greater than C, or A plus C will be greater than B, or B plus C will be greater than A. Okay, sum of any two sides will be greater than the third. Then the fourth point, where we can say that the absolute difference between any two sides must be less than the third side. The absolute difference between any two sides must be less than the third, means the absolute difference between A and B must be less than C. The absolute difference between A and C must be less than B, and the absolute difference between B minus C must be less than A. You know? So these are the most important properties with respect to the side lengths in any triangle. Okay, sum of any two sides must be greater than the third. The absolute difference between any two sides must be less than the third side. Okay, is that clear? Batao. In case of triangles, these are the properties, these are the initial properties that we should know. Now, what else we can say? The perimeter. If the perimeter P is equal to A plus B plus C, if the perimeter is P, which is A plus B plus C, then we can say that P must be less than equal to A, which must be less than equal to, not less than equal to, which must be less than P by 2. Okay, the relation between the perimeter and the side is this, where A is the greatest side, or we can say this about where A is the greatest side. If we talk about the greatest side, then this is the relation between the perimeter and any side, that A is greater than equal to P by 3 and less than P by 2. Okay. Tell me if you have any doubts here. बताओ, कोई डाउट है यहाँ पे किसी भी पॉइंट में? Okay, no doubt. Now, apart from this, again, in any triangle, what can we say about different types of triangles? Okay, different types of triangles. So, one of them will be by side lengths. By side length. So, first triangle is scalene triangle by side length. In scalene triangle, all the sides are unequal to each other. Okay, all the sides are of distinct length. You know. Good evening, Japlu. Okay. Then second is isosceles triangle. Now, in case of isosceles triangle, two sides must be equal, and then comes equilateral triangle. Where all the three sides are equal. Now, remember, in case of equilateral triangle, what we can say, area will be equal to root 3 by 4 A square. है ना? The perimeter will be equal to 3 times A. The height of any equilateral triangle will be root 3 by 2A, and the in radius in any equilateral triangle, the length of the in radius will be equal to A divided by 2 root 3, and the length of the circumradius will be equal to A divided by root 3. These are the lengths of circumradius, in radius. You can find the height, perimeter and area about equilateral triangle. All of these are very important information regarding equilateral triangle and will be used frequently when you solve questions on geometry. Okay. Okay. Now again, in types of triangles, if we consider the angles, then what are the type of triangles that we should know? So by angles, by the measurement of angles, one of them is acute angle triangle. Acute angled triangle. Then the other is right angled triangle, and the third one is obtuse angled triangle. Acute angle triangle, right angle triangle and obtuse angle triangle. Now let's say sides A is less than equal to B is less than equal to C. If A is less than equal to B is less than equal to C, means C is the greatest side of this triangle. What we can say in acute angle triangle, that A square plus B square will be greater than C square. In case of right angle triangle, we can say A square plus B square will be equal to C square. And then obtuse angle triangle, we can say A square plus B square will be less than C square. This is the relation between the side lengths in acute angle triangle, obtuse angle triangle and right angle triangle. So recently इस पे एक क्वेश्चन आया है IPMAT इंदौर में, that side lengths are given, then how many such obtuse angle triangles are possible, how many such acute angle triangles are possible, ठीक है. Now if we try to find, let's say find the type of triangle, let's say question 1, A is equal to 6, B is equal to 7, C is equal to 10. Okay. Second, A is equal to 6, B is equal to 6, C is equal to 3. Third one, A is equal to 8, B is equal to 8, C is equal to 10. Fourth one, let's say A is equal to 7, B is equal to 24, C is equal to 25. And the last one, which we can say, let's say A is equal to 10, B is equal to 14 and C is equal to 15. So what are the type of these triangles by side lengths and by angles? How do we recognize these triangles, right? So how do we find that? In this case, the largest is 10. Can I say 6 square is 36, 7 square is 49, this is less than 10 square, So this triangle will be scalene and obtuse triangle. This triangle will be scalene as well as obtuse triangle. Now in this case, if you check what we can say, if I say that 6 square plus 3 square, this will be greater than, this will be greater than 6 square, yes. So in this case, we can say this triangle will be isosceles and as well as isosceles as well as acute angle triangle. Isosceles and acute triangle. Then the third one, two side lengths are equal. Now if I take 8 square plus 8 square, this will be greater than 10 square. So what we can say, this triangle will be isosceles and obtuse. Isosceles and obtuse triangle. Then in this case, if you check, we can say 7 square plus 24 square is exactly 25 square. So this will be our scalene, but this will be right angle triangle. है scalene and right triangle. Then the last one, what we can say, 10 square plus 14 square is greater than 15 square. 100, 196, 225. So this triangle, all sides are different. This will as well be scalene and this will be acute. So this is how you find the types of triangles, right? If all the three sides are given, how do you find the types of triangles? You find the relation between the side lengths. From there, you can find the types of triangles. So here are the 5 examples, okay? Okay. So till now we have got to learn about the type of angles, complementary angles, supplementary angles, the proportionality theorem. Then we got to know about the triangles properties, the relation between side lengths, then types of triangles by side length, by angles, then the relation between the side lengths. Then comes again few examples of how to find type of triangles. Now we are going to learn a little bit about right angle triangle, right angled triangle. Now in case of right angle triangle, what do we know? This is A, this is B, this is C. Let's denote this side length as A, this side length as B, and this side length as C. So what we can say, that B square will be equal to A plus A square plus C square. So what are the triplets? Some ready-made triplets that we should know is the most basic one is 5 square is equal to 3 square plus 4 square. Then comes 7 square, which will be equal to not 7 square. Okay, then we can say 7 square plus 24 square is equal to 25 square. Then we can say 8 square plus 15 square is equal to 17 square. Then we can say 9 square plus 40 square is equal to 41 square. then 11 square plus 60 square is equal to 61 square. So these are the Pythagoras triplets that you should be aware of. The side length 3, 4, 5, 7, 24, 25, 8, 15, 17, 9, 40, 41, 11, 60, 61. All of these are Pythagoras triplets. In any right angle triangle, if it says that side lengths are integers and one of those values is given, you can find the rest of the two values. Okay. Now apart from this, if we draw a perpendicular to this hypotenuse, let's say D, what can we say about the length BD? We can say BD will be equal to AB into BC divided by AC. Okay. Apart from that, we can also say that BD square will be equal to AD into DC. In any right angle triangle, you should know these concepts. You should know these concepts so that you can apply them directly. Apart from this, there are few right angle triangles that you should know, like 30, 60, 90 degree triangle, 30 degree, 60 degree, 90 degree triangle. In any triangle with the angles 30, 60, 90, the ratio of sides will be 1:√3:2. Then another triangle where side lengths are 45 degree and 45 degree. If the angles are 45 degree and 90 degree, then the ratio of the sides of this triangle will be 1:1:√2. These will be the ratio of the side lengths. Now there is another triangle which is of course not right angle triangle, but we can find out the ratio of the sides is this triangle. Although this you can also find using 30, 60, 90 degree triangle, 30, 30, 120 degree. In this case, the ratio of the side lengths will be 1:1:√3. 1:1:√3. Okay. These are the ratio of side lengths. Okay. Now apart from this, there is also one bonus triangle that I will like to tell you guys, that if there is a triangle which has 15 degree and 75 degrees angles. Now if the side length opposite to 15 degrees is 1, then side length opposite to 75 degrees will be 2 plus √3. And using Pythagoras we can find the third one. Okay. If triangle is 15, 75, 90 degree, then this will be the side ratio. So now you have four triangles: 30, 60, 90, 45, 45, 90, 30, 30, 120, 15, 75 and 90 degree triangles. All right. Now, in case of triangles, what else should we know? In case of triangles, we can also find out the relation between the triangle, the intersection points of different type of lines in a triangle, right? So what are those points and what are the properties of those points? We should know that, right? So there are few lines that we should know. One of them is angle bisectors. Angle bisectors, है ना? And about angle bisectors, what we can say that intersection of angle bisectors of a triangle is known as incentre. Is known as incentre. ठीक है? Let's take one triangle. है ना? Now in this case, in this triangle, let's say this is point A, this is point B, and this is point C. If I draw a line which is dividing this angle A into two equal parts, which is theta and theta. So this AD is known as angle bisector of this triangle. Now if we draw the another angle bisector of this triangle like this angle is alpha, this angle is alpha, then EBE will also be the angle bisector of this triangle ABC. Now you can see that these two angle bisectors are passing through one point. This intersection point is known as I. This intersection point is known as I. Then the third angle bisector will also pass through this point. Like this, CF, okay. If this angle is gamma, this angle will also be gamma. The third, whenever two angle bisectors are passing through one point, the third angle bisector will also pass through that point. Now in case of angle bisector, what do we know? So angle bisector theorem says that AB upon AC will be equal to BD upon DC. AB upon AC will be equal to BD upon DC. Apart from that, you can also know this concept that AB into AC minus BD into DC will be equal to AD square. So these two are angle bisectors theorem that you should know. You must know about the angle bisector theorem. है ना? These two angle bisector theorems are very important. And apart from this, the third one is angle BIC. This angle BIC is equal to 90 degree plus angle A. 90 डिग्री प्लस एंगल ए. देखो अगर ये एंगल 100 डिग्रीज है तो इन दोनों का सम 80 डिग्रीज हो जाएगा, तो बचे हुए इन दोनों को कितना हो जाएगा 40 डिग्रीज. तो ये कितना हो जाएगा 180 minus 40 which is 140. So 90 plus angle A. Angle A means angle BAC. So let me write it clearly as angle BAC. ठीक है? This is angle bisectors and intersection of angle bisector, है ना? Then comes medians. Now what is a median? Median is a line segment which is drawn from one of the vertex of the triangle to the midpoint of the opposite sides. If this is D, BD is equal to DC. BD is known as the median of this triangle. Similarly, we can take another median like this. Then in that case, B will be median of this triangle as well. And these medians are intersecting at point G. This G is known as centroid. So what we can say? Intersection of medians of a triangle is known as centroid. Okay, is known as centroid, which is denoted by G, है ना? If two of them are going through G, then third one will also pass through G. है ना? This F, AF is equal to BF. In that case, CF will also be one of the median. Now, what do we know about properties of medians and centroid? So, first point that we can say that AG divided by GD will be equal to same as BG divided by GE, which will be same as CG divided by GF, which is equal to 2:1. In language, we also call it the centroid of a triangle divides its median into 2:1 ratio from vertex to base. The centroid of a triangle divides its median into 2:1 ratio from vertex to base, which is written here. AD upon GD is equal to BG upon GE is equal to CG upon GF is equal to 2:1. Then comes the Apollonius theorem. है ना? What is Apollonius theorem? That AB square plus AC square is equal to 2 times AD square plus BD square. This is known as Apollonius theorem. In case of, you need to find the median. If all of the three sides are given, you can find the length of the median. है ना? You can find the length of the median using this formula, Apollonius theorem. Tell me, is that clear to everyone? This Apollonius theorem. Okay. So, in terms of medians, this is the formula that you can use. All right. Apart from this, we can also say that in terms of medians, the ratio of squares of the side lengths to the ratio of the sum of squares, which is AD square plus B square plus CF square, this will be equal to 4/3. है ना? This is the relation between the sum of squares of the sides upon sum of squares of all the medians is equal to 4/3. है ना? Apart from that, you can also use this, that if M1, M2 and M3 are the medians of a triangle, then area of the triangle will be equal to 4/3 times square root of m into m minus m1 into m minus m2 into m minus m3, where m is equal to m1 plus m2 plus m3 divided by 3 divided by 2 divided by 2. So if all the medians are mentioned, you can find the area of the triangle directly. बताओ, is that clear? कोई डाउट है यहाँ तक? ठीक है. Now, then comes perpendicular bisector. Okay. Now, in any triangle, intersection of perpendicular bisectors. Perpendicular bisectors are intersection of perpendicular bisectors of a triangle is known as, what can we say? This is known as circumcentre. It is known as circumcentre. Okay. In any triangle, the intersection of perpendicular bisectors of a triangle is known as circumcentre. Okay. Triangle A, B, C. This is one of the perpendicular bisector, not close. One of the perpendicular bisector, the other perpendicular bisector, let's say drawn like this. Then this point we can denote as O. Okay, this is perpendicular, as well as divide these two in equal parts. So the third perpendicular bisector must be passing through this one, like this one. So, oh, not from C, my bad. The third perpendicular bisector will pass through here, pass through A as well. Okay, this point is known as O. Okay, and if we want to find, in case of perpendicular bisectors or the circumcentre, there is not much to learn other than this, that OB will work as radius R. If you draw a circle taking these 3 points, if you join this circumcentre to any of the vertex, all of them will be radius R. Okay, all of them will be radius R, and you can draw one unique circle using these 3 points and this center. Okay, so this is R. What we can say here, that in case of angle BOC, this will be equal to twice of angle BAC, है ना? BAC. There is more about circumradius, which is related to area of the triangle, which we are going to learn all together when we are going to discuss the area of a triangle. Okay. Then comes altitudes. And in any triangle, the intersection of altitudes in a triangle is known as orthocentre. What do we call it? We call it orthocentre. Okay. Triangle A, B, C, है ना? One altitude AD, another altitude BE, then the third one must be passing through this intersection point, which is known as H. So this is F. So as you can see, these are the altitudes, है ना? These are the altitudes, and if the side lengths, if the side lengths are A, B, C, what we can say? A is to B is to C. Or we can say AB is to BC is to AC will be equal to 1 by the altitude opposite to AB. Opposite to AB, the altitude is CF. So 1 by CF is to 1 by BC is the altitude is AD is to 1 by AC, the altitude is B. So you can remember this relation between the ratio of side lengths and the ratio of the altitudes. The side lengths are always in the ratio of the reciprocal of the altitudes, है ना? This one. Okay. अच्छा, यहाँ पे एक चीज़ मैंने छोड़ दी, दिस वाज एंगल BAC बाई 2 है ना, दिस शुड बी BAC बाई 2. Just remember that perhaps I missed writing 2 here. I explained it here, but I missed writing it there. Now, what we can say about angle BHC will be equal to, see, this is 90 degree, this is 90 degree. These two should be added up to 180 degree. If this is theta, this will be 180 degree minus theta. Vertically opposite angle, this will also be 180 degree minus theta. So what we can say, angle BHC will be equal to 180 degree minus angle BAC. है ना? So in each of these points, there is an angle to find. Okay? All right, is that clear? All right then. Now, let's move on to area of a triangle. How do we find area of a triangle? Now, in case of area of a triangle, A, B, C, where the side lengths are A, B and C, है ना? And what we can say, area of a triangle is equal to, it will be half into AB sin C. This you can use, half into AB and this angle C, so sine of C. Okay, then we can say half into base into height, half into base into height. Whatever base you are taking, corresponding to that you will have to take the height. Then area of the triangle can be found using the Heron's formula, which is S into S minus A, S minus B, S minus C, where S is the semi-perimeter, where S is equal to A plus B plus C upon 2. Then we can also find the area of a triangle where R into S, where R is equal to in radius. What we can say about R, where R is equal to in radius, है ना? Then you can also find out area of a triangle if all three sides and the circumradius is given, which is ABC by 4R, where R is equal to circumradius. ठीक है, where R is equal to circumradius. You can also find area in this case, or you can find the circumradius, है ना? If all three sides are given, we can find the area of the triangle using Heron's formula, and you can find the circumradius, है ना? All right. Now, next is similarities in a triangle. Similarities in a triangle, है ना? So, in case of similarities, if we talk about two triangles with similar properties, means let's say there are two triangles ABC and DEF, ABC and DEF. Okay, so if triangle ABC is similar to triangle DEF, है ना? Let's say angle A is equal to angle D, angle C is equal to angle F, then we can say these two triangles are similar. There are other ways to find out that if two triangles are similar or not. Okay, we can find out the ratio of corresponding side lengths. Then we can find out a ratio of corresponding pairs of side lengths and angle between them, and if two angles are equal. In all of these scenarios, we can prove that two triangles are similar, and if triangle ABC is similar to triangle DEF, then we can say, then what can we say that? Then we can say that the ratio of corresponding side, which is equal to AB upon DE, will be equal to AC upon DF, which is equal to BC upon EF. Then the corresponding side ratio will be equal, है ना. थर्ड एंगल तो इक्वल होगा ही होगा, तो साइड्स के लेंथ है उनका रेशियो जो होगा वो भी इक्वल होगा. AB अपॉन DE will be equal to AC upon DF, which will be equal to BC upon EF. ठीक है. And we can say ratio of area, ratio of areas will be equal to ratio of side lengths square. Okay, so instead of side it should be corresponding side. Means corresponding side means AB and DE. You cannot take the ratio of AB and DF or AB and EF. So ratio of corresponding side lengths. What do we write? That ratio of areas will be equal to ratio of corresponding sides square, है ना. Ratio of corresponding sides and square, है ना. Savita, in case of quant formula revision, we are having geometry today. Tomorrow we are also going to have formula revision based on geometry, okay, circles, quadrilaterals and polygons. And then we are going to have formula revision on algebra again, arithmetic progression, geometric progression, spatial progression, right. Apart from that, we are also going to have PNC and probability, all right. So ratio of areas of two similar triangles will be same as ratio of corresponding sides, which is we can write here as area of triangle ABC divided by area of triangle DEF. This will be equal to AB upon D whole square, है ना. This is the ratio of the side length. So area, ratio of area will be AB upon D square. Whatever is given, if these two are given, you can use that too. If these two are given, you can use that too. But area, ratio of their areas will be square of ratio of the sides. Now in case of similar triangles, there is one particular figure which can be used directly in the question. Like this one. Okay. Let's say this is AB, this is C and D, and this length is P and Q. Okay. So using similar triangles, we can prove that 1 by PQ will be equal to 1 by AB plus 1 by CD. Remember this relation in terms of these kind of figures. There is a language of the question, and using that language we got this figure. You know, there are two poles of different lengths A, B, C, D. You know, from top of one pole, a rope is tied to the bottom of the smaller pole, and top of the smaller pole, another rope is tied at the bottom of the first pole. These two ropes are intersecting at point P. What is the height of point P from horizontal, or from the base. This is how you find, right? We can prove this using similarities, but you can use this direct formula, okay? You can use this direct formula in the questions. You just need to recognize the proper language of the question, that you can draw this figure by the information given, all right? Okay. Okay, so we were able to discuss almost every concept that can be used in triangles, that can be used in triangles. So I hope you watched this session carefully, noted down all the formulae, right? So tomorrow we are going to continue this session, and we are going to discuss formulae based on circles, quadrilaterals, and polygons. Okay, so thank you for joining us today. Bye bye.